Hey guys, I just want to make a quick video for you today going over the charges of the ions and how you use the periodic table to figure those out, just to make sure. I've had a couple of questions about this. So you'll remember the octet rule and the idea that atoms will tend to gain or lose electrons until they become like a noble gas. And so if we think about it in terms of that, it makes sense that our group 17 elements, the halogens, they are going to always form -1 ions, because to have a -1 charge means that you had to gain one electron, and if they gain one electron, they'll have the same electron configuration as the noble gases, which do not form any ions and would have a charge of 0. And when we're thinking about it like that, oxygen group is 2 away from being like a noble gas. So they have to gain 2 electrons to achieve a noble gas configuration. And likewise, nitrogen's group 15, will have to gain 3 electrons to achieve a noble gas configuration. So starting from the right side of the periodic table with the noble gases, we have no charge for our noble gases, a -1 charge for our halogen ions, a -2 charge for everything in oxygen's family, and a -3 charge for nitrogen. If we look now at the other side of the periodic table, it becomes easier to lose electrons to achieve a noble gas configuration. So lithium, for example, has an electron configuration of 1s2, 2s1. If it loses one electron, if it loses just its outer electron, it would have a +1 charge, and it would have the same electron configuration as helium. What's the vocabulary word for having the same electron configuration? I hope you just thought isoelectronic. And so lithium and all of the elements in lithium's group will do something similar to that, and they will form +1 ions. Beryllium, group 2, beryllium, magnesium, calcium, strontium, barium, they can lose 2 electrons to achieve a noble gas configuration. And aluminum's group, boron's group 13, these are the something S1, something S2, something P1. So they end with a P1 configuration, so they can lose their P electron and the 2 S electrons to be left with a +3 charge and have a noble gas configuration. What about carbon's group? It's right there in the middle. It's kind of the tipping point. Well, truthfully, these don't usually form ions. When they do, they could be plus or minus 4 for carbon's group. And then we've got, look at carbon's group. It's really a mix of nonmetals, metalloids, and true metals. So tin and lead are true metals. They're below your stair step on your periodic table. Remember our stair step? I don't know if you guys have your periodic tables at home, but the stair step that divides your nonmetals from your metals and your metalloids. So these tin and lead, indium and thallium, they tend to act like our transition metals. So this whole D block is our transition metals. And these have variable charge. They all have positive charges. They all form metal cations, but they vary. Variable positive charges. A lot of times it's +2. They'll lose their 2 valence s electrons. But a lot of times it's something else. Iron can be +2 or +3. Cobalt can be +2, +3, +4. Chromium has a +6 oxidation state or charge that's pretty common. One thing is that your group 12 almost always will form a +2. And then silver and copper usually form a +1. These are not hard and fast rules, and we'll look at how you deal with that. And then your lanthanides and actinides, they also vary. They form a lot of +2 and +3 compounds, but other things as well, plus all the way up to +6, and even occasionally a +7. And so we have several charges or oxidation states available for those ions. All right, so how do we name these? So in the previous lesson, you learned that to name a cation, you just say the name of the element. So calcium, when it has a +2 charge and it's lost its 2 electrons, it's just called calcium ion, and nothing changes. You could say calcium ion or calcium cation to mean the same thing. But for your anions, the ending changes to "ide." So fluorine becomes fluoride, chlorine becomes chloride, oxygen becomes oxide, sulfur becomes sulfide. You get the picture. If it's just a single element acting as an anion and it has gained electrons to have a negative charge, then the ending becomes "ide." And so when we stick these together to make a compound, so let's pick fluorine with its -1 charge. So its name is fluoride. So by itself, it's the fluoride ion or fluoride anion. When I stick it together with calcium to form a compound, the charge has to be balanced. For every positive charge, there has to be an equal amount of negative charge. And so +2 calcium, I need 2 -1 charges, so I'm going to need 2 fluorines. So the formula is going to be CaF2 to show that I need 2 fluorine atoms for every calcium atom. And then I don't show any of the charges in the overall molecule. The charges are balanced. They are not shown in the formula of the molecule of the compound. We don't really call those molecules, but that's a lesson for a different day. So your salt formula here, your calcium metal cation, your fluorine, fluoride, nonmetal anion, 2 of those to every 1 calcium. When you need 1 of something in your formula, the 1 is understood. We don't have to show it. It's not wrong if you show it. So if you put your 1 in there, it's okay. So CaF2, and the name of the compound would just be calcium fluoride. Oops, I did what I tell y'all not to do. Fluoride, calcium fluoride. Hope that helps clear some things up for you. As always, send me questions on Remind or on email if you want to, and I'm going to make another lesson for you about polyatomic ions. Have a great day.